Assume the resting metabolic rate, RMR, of healthy males in complete silence is 5,710 kilojoules per day. Researchers measured the RMR of 45 healthy males who were listening to calm classical music and found their mean RMR to be 5,708.07 with a standard deviation of 992.05. At the alpha equals 0.05 level of significance, is there evidence to conclude that the mean RMR of males listening to calm classical music is different than 5,710 kilojoules per day? Let's write down all the given information. First, we have that the mean RMR is 5,710 kilojoules per day, and this will be mu naught. We are told that the sample size is 45, which is n. We are given the sample mean, which is x bar. And we are given the sample standard deviation, which is s. In order to answer the question, we need to perform a hypothesis test for the population mean. First, we have to check the following conditions. First, we have to check that the sample is obtained using simple random sampling. We can assume that the sample is random, so this condition is satisfied. We also have to check that the sample has no outliers, and the population from which the sample is drawn is normally distributed, or that the sample size is large, which means that the sample size is greater than or equal to 30. The sample size is 45, so the sample size is large, so this condition is satisfied. Now we have to check that the sampled values are independent of each other, or that the sample size is less than or equal to 5% of the population size. The sample size of 45 is definitely less than 5% of the population size, so this condition is satisfied. So because these three conditions are satisfied, we can move on to step 2. In step 2, we write the null in the alternative hypothesis. Let's start with H naught. The question is asking about the mean RMR, so the null hypothesis will involve mu. And the null hypothesis is always equal to some value. And this is equal to the given population mean, which is 5,710. Now let's write the alternative hypothesis. The alternative hypothesis will also have mu, and the question wants to know if the mean RMR is different. So we will use not equal to. And we will always have the same number as an H naught, so this is mu not equal to 5,710. Because the alternative hypothesis contains not equal to, this is a two-tailed test. Now let's move on to step 3 and determine alpha, or the significance level. We are told that alpha equals 0.05. For step 4, you can either use the p-value approach or the classical approach. First, we will use the p-value approach. Let's compute the p-value in StatCrunch. Let's go to Stat, T-stats, one sample with summary. Let's type the sample mean here, which is 5,708.07. Now let's type in the standard deviation, which is 992.05. And now let's type the sample size, which is 45. We are doing a hypothesis test for mu, so we will select this option. For the null hypothesis, we have that mu equals 5,710. And for the alternative hypothesis, we have mu is not equal to 5,710. Now let's press compute. And we have the t-stat here and the p-value here. The p-value is approximately 0.9896. Now let's compare the p-value to alpha. 0.9896 is greater than 0.05, and we have that the p-value is greater than alpha. So we do not reject H naught. Now let's write the conclusion. Because we do not reject H naught, there is not sufficient evidence at the alpha equals 0.05 level of significance to conclude that the mean RMR of males listening to calm classical music differs from 5,710 kilojoules per day. Now let's use the classical approach. We start with the classical approach at step 4. First, we have to compute the test statistic T naught. Now let's substitute the values. Type this in your calculator, and we get approximately negative 0.013. Now let's find the critical value. First, let's draw a sketch. This is a two-tail test. So we will have a rejection region in both tails. We split alpha into these regions. Alpha is 0.05, but since we have two regions, we have to split alpha in half, so we get 0.025 in each of these tails. Because this is a two-tail test, we will have two critical values. Now let's go to table 7 to find the critical values. We have that the area in the right tail is 0.025, so we will use this column here. And the degrees of freedom will be the sample size minus 1. So the degrees of freedom is 44. The closest number to 44 is 40. And now we select the corresponding critical value. And this is 2.021. So we have that the critical value on the right side is 2.021. And because the t-distribution is symmetric, the critical value on the left will be negative 2.021. Now let's plot the test statistic t0. Recall that t0 is approximately negative 0.013, which is approximately here. Notice that t0 is not in the blue region or the rejection region. So we do not reject h0. Now let's write our conclusion. Since we do not reject h0, we say that there is not sufficient evidence at the alpha equals 0.05 level of significance to conclude that the mean RMR of males listening to calm classical music differs from 5,710 kilojoules per day.